Welcome to EDU World Space.
Problem 3.85. In this problem, we have to calculate equivalent force coupled system at point D. So, for the equivalent force, we can observe here that only one force is acting at point B. So, the force itself will be the equivalent force. So, we can say that equivalent force at point C, that is R, will be 360 Newton, and its angle from horizontal axis, let's say this is the force and this angle is theta, so theta will be, we can see here, if we apply a horizontal line, so this angle is 40, so this angle will be 50 degree. So from horizontal it is going to make an angle 50 degree. So this is the value of equivalent force. Now if we want to calculate the equivalent couple about at point D, for that we need to write the force in its vector form, and for that we need to define a coordinate system. Let us say this is our y-axis and this is x-axis, and origin is at point D. So origin is at point D, so we can say that here is the y-axis and this is x-axis. So now we can write this force. Let's say this is F, so let's say this is F, so we can write F in vector form as both the components will be, one component in the horizontal direction will be negative x direction and the vertical component will be negative z direction. So we can write its component as minus 360 sine 40 I cap, and its j component will be plus minus 360 cos 40 j cap. So from here the value of F comes out to be minus 231.4 Newton I cap, and this will be negative, so it will be minus 275.78 Newton j cap. Now to calculate moment, equivalent moment about point D, we have to find the position vector of point B with respect to point D, and that will be, since we can observe here that point B is in negative x direction but in positive y direction, so its x coordinate will be negative but y coordinate will be positive, so we can write it as minus. And now if we talk about this distance, so this is 0.35 meter, this is 0.3 meter, so BD length is going to be 0.65 meter, so this will be 0.65 cos 30 I cap, and its j cap component will be 0.65 sin 30 j cap, so which turns out to be minus 0.56 I cap plus 0.325 j cap. Now we can calculate the moment about point D, which will be position vector of point B with respect to point D multiplied by the force vector that is acting at point B, and we can put these values, so all these are in vector form, so this is going to be a cross product, so this will be 0.56 I cap. Alright, so this position vector is negative, so this will be negative sign I cap plus 0.325 j cap cross multiplied with minus 231.4 Newton I cap minus 275.78 Newton j cap. And now we can solve this by using determinant method. So we can form a determinant here, and that will be, this is I cap, this is j, and this is k. So I coefficient will be minus 0.56, here 0.325, and this will be 0, and the third row will be minus 231.4, this will be minus 275.78, and this will be 0. We can observe here that if we expand about I cap, so this column is going to be 0. If we expand about j cap, again the one column will be completely 0. So both of these coefficients is going to be 0. The only coefficient left will be because of k cap, and that will be k cap, and its coefficient will be minus 0.56 multiplied by minus 275.78 minus minus 231.4 multiplied by 0.325. So now we can solve this. So this comes out to be 229.64 k cap. So this k cap is positive. It means that the couple, that is the equivalent couple at point D, will be in counterclockwise direction. What it indicates? It indicates counterclockwise direction. So we can show here the point as equivalent force. This will be R, whose magnitude is going to be the same, that is 360 Newton, and its angle from horizontal axis will be 50 degree, and this is the point D, and here a couple will be acting of M, and whose magnitude will be 229.64. So this was the first part. In second part, they are saying that two forces are applied at points A and D. So let me draw this A and this diagram once again. So let us say this was the diagram. So this is point A and this is point D, and two forces, one force that is acting at point A is in vertically downward, is vertical force. So this is, let's say, F1, and then another force, so they haven't mentioned about its direction or magnitude. So in general case, I'm going to consider a force here whose magnitude is F2, and it is making an angle theta with the horizontal. So we have to find these values F1, F2 and theta. So first of all, we have just calculated above that moment here. The moment was 229.64 Newton meter. So we can use this here to calculate moment about D in this equivalent diagram. So if we calculate moment about D in equivalent diagram, it comes out to be F1 multiplied by the perpendicular distance. So this will be the line of action, and this is going to be perpendicular distance. So this length ED in the problem is given as 1.05 meter. So this is 1.05 meter, and this angle is given as 30 degree. So this perpendicular distance will be 1.05 cos 30. And equivalent moment we have calculated here, that was 229.64 Newton meter. So from here we can get the value of F1, which will be equals to 229.64 divided by 1.05 cos 30, and it comes out to be 252.54 Newton. So we got the value of F1, that is 252.54 Newton. Now the two unknowns are remain, that is F2 and theta. So now we can apply the force balance. Now we have calculated above that equivalent force at point D, here we can see, was 360 Newton. So if we convert it into J cap and K cap components, so this angle was 40 degree. So this was R cos 45. So we can once we write this force, equivalent force at point D in vector form, and that was 360 cos 40 minus J cap and plus 360 360 sine 40 minus I cap, and we can balance this by the equivalent force that is acting in this equivalent system. So in j cap direction, two forces are acting, that is F1 and F2 will also have a component in j cap direction. So we can write it as F1 since it is acting in negative direction, so minus j cap, and plus we can write it from here F2 cos theta. Cos theta component will be in horizontal direction, so minus I cap plus F2 sine theta minus j cap. Now we can compare the coefficient of I cap and j cap from both the side. So if we compare the coefficient of I cap, here the coefficient is minus 360. So comparing coefficients of, if we compare the coefficient of I cap first, so this will be minus 360 sine 40, and this would be equals to the I cap coefficient. Here only one term is containing the I cap, that is F2 cos theta minus F2 cos theta. So minus gets cancelled out. So from here we can write it F2 cos theta is equals to 360 sine 40. Let us say this is equation 1. Now if we compare the j cap coefficient, so j cap coefficient here is minus 360 cos 40, while here the j cap coefficient is, if we solve here, this is minus F1, and from here this is minus F2 sine 40. Now if we take this term left side of the equality, so this becomes, sorry, this is F2 sine theta, not 40. So this is F2 sine theta. So F2 sine theta is equals to 360 cos 40 minus F1. We have already got the value of F1 above, and that is 252.54. So we can use this here. So this comes out to be F2 sine theta is equals to 23.24. Now so F2 sine theta is equals to 23.24. Let us say this is equation 2. Now if we divide the equation 2 by equation 1, so by dividing equation 2 by equation 1, so it comes, we can write here. So first we have to write the equation 2. So this will be F2 sine theta is equals to 23.24. Now we have to divide this by F2 cos theta. So this will be F2 cos theta, and here this will be 360 sine 40. Now F2 gets cancelled out, so this equation turns as tan theta is equals to 23.24 divided by 360 sine 40. So from here we can get the value of theta, which comes out to be 5.735 degree. Now we can put this theta in equation 2 or in equation 1. So in any equation we can put. So if we put it in equation 1, putting the value theta in equation 1, so F2 comes out to be 231.4 divided by cos theta, and we can use calculator to solve this value. So it comes out to be 232.56 Newton. Hence we can say that we would have to apply two forces. The vertical force will be of magnitude 252.54 Newton, and the another force that is applied at point D will be of magnitude 232.56 Newton, and its angle will be 5.735 degree from horizontal.